Good afternoon and welcome to today's industry-presented webinar, Protein Myths versus Facts, what active individuals need to know about protein intake, timing, and more. A few housekeeping things before we get started. This is a voice-over IP webinar. It's totally web-based. If you experience audio difficulties or if the video begins to buffer, it's likely caused by the strength of your internet signal. If you are having issues, log off and log back on. If you do have a question during the webinar, please type it into the question area within the GoToWebinar navigation, and we'll get to as many as we can at the end of the presentation. If your question goes unanswered, we'll take additional questions from today's webinar and post answers as a blog on the ACSM website. We also encourage you to join the conversation about today's webinar on Twitter by using the hashtag ACSMcertified. Today's webinar is sponsored and presented by Cliff Bar & Company. Cliff Bar & Company crafts nutritious and organic food to feed and inspire adventure, including the Cliff Bar Energy Bar, Cliff Kid, nourishing kids in motion, and Luna, the whole new Bar & Company will be emailed to all participants after the webinar. You should receive the CEC email and a link to the presentation within the next 1 to 2 days. There is no need to email ACSM asking about CEC credit. Today's webinar presenter is Dr. Mike Ormsbee. Dr. Ormsbee is the Associate Director of the Institute of Sports Sciences and Medicine and an Associate Professor in the Department of Nutrition, Food, and Exercise Sciences at Florida State University. From his days as an NCAA collegiate ice hockey player to competing in 70.3-mile Ironman races to helping others achieve their performance goals, he has always used evidence-focused training and nutrition strategies to optimize performance and body composition. It is with great pleasure that we present to you Dr. Mike Ormsbee.
All right. Hello, everybody. I'm going to share my screen now so you can see what I'm looking at here. I am thrilled to be here. It's really a pleasure to be invited to do this on behalf of Cliff Bar and ACSM, and to present you some basic things that I've been working on and in for a long time with regard to protein and various myths and facts that have come from our research, and as well as collaborations with others around the world. I wanted to just take a minute and make sure that we're all clear with the learning objectives from this particular webinar, which are listed here. So basically, we're going to go through some of the physiological and metabolic differences that influence protein needs, and that's going to be a big crux of how the webinar is laid out. And this will be between sedentary as well as active individuals. We'll also go through some various nuances regarding protein distribution and how perhaps distributing it throughout a day might be optimized to lead to some goals such as hypertrophy or weight maintenance or weight loss or even performance. And lastly, we'll look through factors that influence the amount, type, and timing of protein that's needed for a couple of areas: health, body composition, and somewhat with performance as well. So a lot to cover today, and we're going to sort of just hop right into here. But first, I need to just make it clear that I have a few disclosures and funding areas that just need to be identified. First and foremost, Cliff Bar is sponsoring this talk, and I'm an advisory board member for Cliff. I also serve in that capacity for some various other companies, and have had funding from these over the years to have our work come out and be published. So I just want to make sure that that's clear with everybody, and we'll move through to the rest of the talk. So the first piece of information that is really worth looking at is shown here. So there's information from the International Food Information Council Foundation that looks at sort of where healthy trends are going and what people are thinking about eating these days. And the point of this particular slide is shown right up here. The right mix of different food groups is where I want you to pay attention to, which shows that nearly 6 in 10 individuals are saying that a healthy eating style means getting the right mix of different foods. So that's really important to folks. So people sort of see that mixing foods in a way that works for them is a good idea, but the confusion over protein in particular is where we're going to focus our time on today. And so there's certainly some myths, some things I hear all the time, giving lectures all over the place about our research and protein in particular, and come up at conferences time and time again. So that's really what our aim is today, is to really knock out those particular nuances so that it's quite clear for everybody. In this protein trends data that sort of set the pace for where we're going here, some of the trend is that protein itself is increasingly marketed as a healthful component of food products. And it even has what we call a health halo. So even if a food may not be the most advantageous for your health, if there's a protein label on it of some sort, people are seeing that as a healthy option because of this health halo. So that's an interesting thing to work around in the real applied aspect of this. The other part is that 2/3 of consumers said that they considered protein when deciding what to buy. And so I think people are starting to look at this stuff more and more, at least from a marketing trends perspective, but also from a citations perspective. Borrowed this figure from Stu Phillips and it said PubMed search on protein supplementation and hypertrophy, and it just has gone up and up over the years through 2017 being the highest amount of searches that folks are looking at. So quite a big interest in protein in general. And what that's led to is certain beliefs about what protein will do for individuals. And so from these data, there's some evidence that many people think that protein will help to maintain energy, build muscle, feel full or satiated or less hungry, and also that it may aid in weight loss. So that's kind of where some of the beliefs are going, but there's certainly some myths mixed in there, which we'll cover today. The other part is about what are people actually eating in terms of consumption. We'll spend a good bit of the time in this particular talk going through that. But just from 2009 to 2010, it looked like men who are older than 20 years old were having roughly 16% of their diet coming from protein, and then women of the same age range were having roughly 15% of their diet coming from this. And what's interesting is that the acceptable macronutrient distribution range for protein is between 10 and 35%. So looking at these 2010 numbers, this is the very low end of what the range is that's set right now as the acceptable macronutrient distribution range. And so Stu shared this with me just because I really wanted to get across some of the physiology behind how this works in terms of eating protein and what that does to muscle protein synthesis or building muscle, and also muscle protein breakdown or breaking down the muscle. And the way that we have to think about this is actually twofold, because there are two processes that are competing, the synthesis or building side as well as the breakdown side of this. And it's the balance between building and taking away that ends up with how our muscle responds to that protein intake. So here in this nice theoretical model, you have a protein intake early in the day. That stimulates in yellow what's shown as muscle protein synthesis. And so that's really where we're building our muscle mass at that time. At the same time, you have a reduction in muscle protein breakdown shown in red. And so the green area encapsulates the synthesis side of this. So it's been a while since you've eaten. Some of the, basically you're going to start offsetting these. And so you'll have a synthesis dropping as you haven't eaten in a long time, the breakdown side rising as you haven't eaten in a while, and that's shown here by this gray area where you have more breakdown occurring than synthesis, where you'd have a loss of muscle. So you eat your next meal, let's say it's lunch at this time, again you have an increase in synthesis and a reduction in the breakdown side, and then again on through dinner. And so you can see this sort of ebbs and flows through the day. And if you wanted to not change muscle mass, then you would want these things balanced so that your synthesis and your breakdown at the end of the day were equaling out. And then what that also leaves is the potential for us to talk about other opportunities for protein feedings when you might be in this gray area for a longest period of time, which is an area that our lab's been highly interested in, which is pre-sleep feeding, and we'll go into some of that today as well. So that's really the basics on the biology of what's going on with this particular topic. Now that's at the the rested state. So what's interesting is that if you add exercise to this model, and obviously we want to promote activity and physical activity, this changes slightly. So in this case, we'll talk about resistance exercise, which is shown here. And what that does is it augments or changes the synthesis side. So you actually have more protein synthesis occurring, and at the same time, you have a blunted or a reduced muscle protein breakdown. And so that's pretty much a win-win scenario, so that if you combine exercise, in this case resistance exercise, and protein intake, then you end up getting this scenario where you have a heightened fed state muscle protein synthesis, and you have a reduced fasted state muscle protein breakdown. All in all, sort of a net win. And in theory, that if this accumulated over time, say months of time, then you might be able to add some muscle mass to your body. And that should come along with some fundamental changes that are useful, like strength and power and those types of things. So that's really the background upon which we're going to lay some of the myths that we'll talk about coming up. And so do protein needs differ between active and sedentary people? The short answer is going to be yes, but that everybody really needs to consider eating more than what's currently recommended at the 0.8 grams per kilogram per day. And that also we have to consider that exercise is critical to this. We just saw it, and that it gives a more robust response to protein intake or feeding in general, as sort of primes the muscle to be able to handle the protein dose that comes with it. And ultimately, the range of intake for sedentary or for active individuals is somewhere between 1.6 and 2.2 grams of protein per kilogram of body weight per day. So if you were to look at this high end, that's about 1 gram of protein per pound that you weigh. So quite a bit higher than the current recommended dose of 0.8. And that's really where we'll have some discussion today. I wanted to show this image, and I'll show it again later as well, but it's a neat study that was looking at resistance training over time in older individuals. And so the 0.8 line is protein intake along the x-axis in grams per kilo per day. So that's what's currently recommended. And then over here on the y-axis, you have the change in fat-free mass, or the change in muscle mass. So basically, are you increasing or decreasing muscle, and how much protein are you taking in? And this is in 50 to 80-year-old individuals who are also resistance training. And what I want to highlight here is that the RDA for protein, if you're eating that amount and you're an older individual, it actually equated to a loss of a small amount, but 0.2 kilograms of fat-free mass after 12 weeks, even with resistance training. So what that highlights is that if you're resistance training, trying to maintain or build muscle as an older individual, and you're eating what's recommended at 0.8, you're still losing muscle at that time. And so we'll talk about some age differences and how much protein we actually need to take in to see a difference. But again, we sort of let the cat out of the bag earlier, where it's way up at this end of the range when you start seeing the line cross the zero change mark, and you start seeing some benefit. Interestingly, Morton, so from Stu Phillips' lab, they started to look at some data accumulated over time. So it was really taking many studies that existed in these big meta-analyses, and what they did is this linear regression analysis with this breakpoint. And what they were able to show was that in these folks, 1.6 grams of protein per kilogram per day was about where the muscle protein synthesis in terms of change in fat-free mass occurred. So having roughly double the recommended daily allowance is where individuals started having the best result, and the top of the end of the result for adding muscle mass. But notice that the confidence interval is big, all the way down here towards 1.1, and then all the way up towards 2.2. So right on average, you're looking at 1.6, but it could be as high as 2.2 for some of these changes in fat-free mass to occur. We recently published a study that is in press at the moment, and found very similar results in that in men and women, if you consumed, it was just over 2 grams per kilogram of body weight per day, as compared to just about over 1, so it's double the amount of protein, that's when we saw the best benefits to body composition, and that's also when we saw the best benefits to strength, at least in the men. And that ended up really playing out with the whole host of data that exists now. And so if we look at what others recommend at this time for sedentary and active individuals, the consensus is really 0.4 grams per kilogram of body mass per meal. So per meal, so you end up stimulating muscle protein synthesis. That's an interesting output. And also want to draw your attention down here, which mimics what I've been saying, 1.6 grams per kilogram per day. Other groups have also published this similar sort of data. Here's a position stand on protein and exercise, and want to highlight again here, 1.4 to 2.0 was the consensus statement from this position stand, which I was a contributor to. And so we'll go through sort of how these things play a role in our myths. And so the myths we're going to actually get into are, one, that Americans eat too much protein in general. I want to make sure that we cover this topic because I do hear this a lot, and there are some things to really discover here that I think will be interesting to folks, that we may not be actually doing that. Myth 2 will be a 20-gram dose of protein is all you need in terms of optimizing muscle protein synthesis, and that protein timing doesn't matter at all. So does it matter when you eat it? So I want to share some data there. Myth 3 is that a lot of people think that eating too much protein will make them gain fat, and we'll walk through just how that's panning out in the data. That's really not showing that at all. In fact, it's quite difficult to gain fat with a high protein diet. And then the last one will be myth 4 for weight loss. Some folks recommend reducing your protein intake as well as the other macronutrients, carbohydrates, and fat, and we'll make a good case for why that's probably not the best idea. So let's start with myth 1, Americans eat too much protein. So this is coming from a number of things, but perhaps media headlines that you're eating too much protein. This is one that we just clipped out, you're eating way too much protein. So that's interesting. We also know that if we really only need 0.8 grams of protein per kilogram of body weight, which is about 0.35 grams of protein per pound of body weight, then we may be eating enough. But I've just covered already that that's probably half as much as we need, whether you're sedentary or active. So it's still a myth. And then Americans eat close to the RDA in general. So we might be eating close to 0.8, but we also know that that's far too low and probably not varied enough. So let's get into some of the data supporting this. So here are some facts about it. The average intake of protein foods are close to the recommended amounts, but the recommended amounts are too low. And so that's where some of the confusion comes in. And there's some references here that if you choose to follow up with, you can see some more. But this is our protein foods area, and then showing intake at or above the recommendation is coming in up at a pretty good range, roughly 60% of people coming at or above, and roughly 40% coming below. So it's kind of right in the middle. But one thing to note is that there are guidelines now that type of proteins and actually changing protein sources, so swapping animal sources for perhaps legumes, nuts, and seeds, and really varying where the protein is coming from in your diet, certainly can help support a micro and macronutrient dense eating pattern, and could be really leading to some healthful patterns by using more than one protein source. And we'll kind of get into that as we move through here as well. So I wanted to show you some data from 2011. It was looking at older data, but what it's showing here, this is NHANES data, so huge national surveys of what people are eating. This is everybody together, so all individuals. This is the normal weight individuals, this is the overweight individuals, and this is the obese group. And in every single instance, the percent of calories coming from protein is on the decline, at least in these data. So that means that compared to older numbers, people are eating less protein as a percentage of their total diet. And there's a few reasons for that. One of them is that the calories are overall are going up, so people are eating more food in general. And as they're doing it, they seem to be eating a more carbohydrate specific type diet as opposed to a protein specific diet. So you can see here carbohydrates on the rise over time, whereas proteins sort of hovering at a lower level since the 1980s in this particular example, and fat staying pretty consistent. And so therefore, as a percentage, our protein intake has been going down. Much more recently, Claire Berryman, who's a colleague here at FSU, published some work that was looking at protein dosing as a percentage, looking at lots and lots of data points. And what this is indicating here is the range set by the AMDR, that acceptable macronutrient distribution range. And if we look at most people for this audience, probably 19 to 30 on up, and you can see this hashed black bar is the bottom at 10%, and this top one is 35%. And it mimics the data we've seen in that people are eating roughly 15% of their calorie intake from protein, and that's certainly at the very low end of the AMDR. So that's some really interesting information that we may not be eating as much protein as we think, and as a percentage, it seems to be certainly on the low end. One real interesting study that I was part of that we published just last year that was led by one of our former doctoral students, Dr. Joe, and he was interested in looking at clinically obese individuals. And so these individuals came to a bariatric center to get surgery or to inquire about surgery, and instead we sort of roped them into volunteering to do a study with us, and where we added protein to their diet, which was a medically induced very low hypocaloric, low calorie diet, and resistance training. And just real gently here, we'll mention that their mean initial body mass was 126 kilograms. And then their absolute daily protein intake at the start of this was 70 grams. And so if you do the math on that, and simply it shows us that these individuals who were very obese were eating 0.55 grams per kilo of protein, which is below the 0.8 grams per kilo recommendation that is currently set, and far below the doubling of that we're recommending now at 1.6 grams per kilo. So in this case, some of this is driven by just larger sized individuals and then not eating enough protein when you're dosing this on a grams per kilo basis. And when we're dosing it on a percentage basis, it's still at the very low end. So all those things sort of aligned. And so this is where we stand now. On a grams per kilo basis and a percent, Americans do not eat enough protein. And the myth largely is due to this increasing body size, and that's kind of something we just explained there. And lastly, it's important to note that we are recommended by our guidelines to sort of get a mix of where our protein choices are coming from. And so that includes changing things like seafood or swapping some animal sources for plant sources, which is a very hot topic now in many areas, marketing as well as the research world. And our lab is actually looking at some of that right now. So the key takeaway is that your clients likely do not eat enough protein on a per kilo basis or as a percentage of dietary intake. And so when we're sort of recommending practical guidelines for people, it's typically a protein forward approach where they look at protein first in their diet and then fill in the carbohydrates and fats. But there's certainly multiple ways to go after that. So the second myth to talk about today is the dosing. So how much dosing do we need to really have a proper response in terms of muscle protein synthesis? So the myth is that a 20-gram dose is all you need and that protein timing doesn't matter. So I want to show some data here. This is really interesting work that was coming from Dan Moore and Stu Phillips. And what they were showing over time was a response to resistance exercise. And so after resistance exercise, they dose people with 0, 10, 20, 30, or 40 grams of protein shown down here on the x-axis. And over here is our muscle fractional synthetic rate, which is a marker of muscle protein synthesis. And so you can tell that as you had more protein, you had an increase in your muscle protein synthesis as shown by the dark line. And it basically capped out at about 20 grams. And so here you can see that there's no difference between 20 and 40 grams in terms of muscle fractional synthetic rate or muscle protein synthesis. So the recommendations became about 20 grams as a dose. But what we need to also consider is that there's a range here. And it spreads, right? So not everyone's lining up right here, and it could be lower, say 15 grams or up towards 25. And a lot of that depends on how big somebody is, their individual body mass, their goals, etc. But roughly 20 grams is shown in these young men to stimulate maximal muscle protein synthesis. And what that came out to be was, by the way, this was egg protein, which is largely seen as the international gold standard for price of protein. And it came out to about 0.25 grams of protein per kilogram of body mass per meal. So if you're doing this per meal, it'd be these numbers like 0.25, and but as just a bolus dose, it was roughly 20 grams. But that's not the end of the story, because there's certainly some more nuances to this, and we need to think about exercise or non-exercise and how old somebody is. And so I wanted to share this one, this particular study, which was really interesting because we need to remember the initial biology that I showed you, is that there's more to protein than just muscle protein synthesis. There's also the muscle protein breakdown side. And so what this particular figure is showing is that on the x-axis, there's a balance, so a net balance, nitrogen balance scenario, where we look at the addition or the accumulation of the synthesis side, which is shown here, protein synthesis, and the breakdown side, which is shown here as protein breakdown. And then they dosed the people a little bit differently. So they did 40 grams or 70 grams of protein. And they did it in either the rested state, which is the R, or the X, the exercise state, which is shown in the black bar. So if we look across the board on this, the thing to pay attention to is that the overall balance is what we probably need to be looking at, and not just the synthetic rate. And here you can see that there's certainly some advantage to a higher dose. This is a 70-gram dose. And also the breakdown side makes a big difference. And so with the 70-gram dose, they had less muscle protein breakdown, which results in a better net protein balance. All right, so that's what's really interesting across the board here. The other thing that was sort of nuanced was the exercise versus resting component to this. But it really, for me, what the take home was is that the higher dose may not do any more for muscle protein synthesis. You can see it's quite minimal, but it did more for the muscle protein breakdown side. So Rob Wolf's data is excellent, and this is some of the information that sort of came from that area. All right, so more perhaps better for overall net protein balance. And if you compare younger and older individuals, this is all data that was shown from Stu Phillips, Dan Moore, and some others out of that particular lab at McMaster. They were showing a couple of really neat things. So again, looking at muscle protein synthesis in younger individuals with one of these linear regression plots, and you can see that the average here is on a per meal basis for younger individuals was about 0.24 grams per kilo, with the range being 0.18 to 0.30. And then over here in the older group, what's interesting is that whole curve shifted right. So as everything shifted right before you end up having your linear breakpoint, what that means is that for older individuals, they actually required a higher dose of protein to optimize their muscle protein synthesis rate. And it was a little bit higher at 0.39, with the range being somewhere between 0.21 and 0.57, because obviously there's some differences between individuals that need to be accounted for. So as a per meal basis, it looks like older individuals need some more. And then this is what I was showing earlier, but again, in older individuals, if you're eating the RDA, you just don't respond as you might want to, even with resistance exercise. And so this term has been coined anabolic resistance, which is where older individuals just don't have the same muscle protein synthesis response to the same dose of protein. So in older adults, there's this reduced skeletal muscle protein synthesis after protein intake compared to younger adults. And this resistance, anabolic resistance, is thought to be overcome by higher protein intakes. So that's just really something that we need to consider, that each time an older person eats, they get a little smaller muscle protein synthesis response. And so they would need to eat more protein and resistance exercise to have the best outcomes. And this is all kind of related to a timing of protein intake, which is one of our aims of this webinar. And does it really matter? There's conflicting evidence that's coming out all the time on this. And I want to just show a little bit of work from others and from our lab that have looked at this. This particular one was published in 2013. And what I really like about this is they gave 3 different types of interventions, but all were giving 80 grams of protein. And maybe for you all listening, if you can imagine which one of these scenarios you typically eat or recommend. So there was a bolus feeding in which they had 2 40-gram doses every 6 hours. So throughout the day, they just had 2 40-gram boluses. There was an intermediate group that had 4 20-gram doses, so it was more evenly spread throughout the day. Or they had a pulse, which was 8 10-gram protein feedings every hour and a half. So it was rapid, repeatedly done over the course of time. And during that time, blood and biopsy samples were taken by this group. And some interesting things came out of this, in that the intermediate group, who had 4 20-gram boluses, and the boluses were every 3 hours. This is myofibrillar, so the contractile component of muscles, protein synthesis rate, was greatest at 4 to 6 hours and 6 to 12 hours after exercise and ingestion of this for a muscle protein synthesis response, and then taken as a whole. And you summed up all of these data, then you can see again here the intermediate group is the one that fared the best in terms of muscle protein synthesis. Now, I'm aware of data conflicting with this, but in my opinion, that this is a very advantageous way to eat, to perhaps get a little more bang for your buck out of your protein bolusing. And the thought is that these little teeny 10-gram doses don't do enough to stimulate muscle protein synthesis, and that only maximizing synthesis twice a day also is not ideal. So that's the basics behind that. What's also interesting is that the timing of this has been looked at. So Brad Schoenfeld published a paper with some others in 2013 that really took a view of all the literature to date that had looked at protein timing around exercise. And what they found were pretty neat. This is a muscle growth slide. So every figure, every author listed on the left-hand side this is what they found, and then the black dots indicate was it advantageous or not to favoring treatment. So this x-axis, if it's to the right of the dotted line, it means it favors a protein treatment in this case. If you look at the overall bullet, which is highlighted by this arrow, you can see that there is a favorable effect on muscle growth to having protein and what they say is close temporal proximity to exercise. So right before, right after, or even during exercise. But the key is that it's pretty small, right? So the effect is shifted right, which would be a good thing, but it's not huge. It's just that there is something going on here. So it's interesting, but when you adjust for total protein intake and not just the timing of it, some of these effects almost entirely disappeared in this review and from 2013. There's some controversy around this review and were all the right papers included, et cetera, like any research study. But what I'm getting from it is there is a small advantageous effect. It's just not nearly as big as we might have thought. So more recently, it was looked at. More studies have been included in this type of an analysis, and this particular one was by Phillips group again, and they divided it by trained and untrained individuals. And so that's a really interesting way to look at it. So the blue arrow indicates again this diamond that is showing that there's some effect for favoring protein, but it's very minimal, and that this overall effect is pushed by the trained individuals. You can see that this white diamond is pushed furthest to the right, and that's driving the total effect also to the right. So this means that for individuals who are trained, you are having a greater response to muscle protein ingestion, to protein ingestion in terms of your synthetic rate. So I think that's a neat point, is that the trained individuals fared a little bit better with protein intake. So from that review, they tried to tease out differences in training versus protein. And I want it to be understood that resistance exercise any day of the week is outdoing our protein supplementation for increasing strength and fat-free mass. So from this review, this is a summary of all the data collected. This is a 1 RM for the leg press. You can see that just the exercise alone in this gray area had a pretty robust response in terms of changing 1 RM when you accumulate all the data that's been looked at. There were lots and lots of studies sorted through. I think 49 ended up being included in this paper, in this big meta-analysis and meta-regression. But protein ingestion added 9% in a favorable direction to this change in 1 repetition maximum. The other side of this is the fat-free mass side. And from a fat-free mass perspective, exercise training is extremely valuable in being able to add fat-free mass. And the addition of protein added about 27% to the final outcome in terms of fat-free mass. Now, this looks huge, and I know that a lot of times we're talking about minor gains adding up over time. But if you look at this scale, this is really ends up being roughly 2 pounds or kilogram of change over time at best. And so you have to debate, is that worth it? Certainly there is effect, it's just small. And so if you're a bodybuilder or you're someone who's very interested in muscle mass and strength and things over time, then certainly there's an advantage to doing this. Now, a couple of years back, Paul Arciero, the lead on this study, and I teamed up with some others to look at meal frequency over time. So again, on the timing issue. And we designed this study to look at a control phase, so a baseline controlled diet. So it was 5 days of a controlled diet. And then it went into a balance phase, which is our energy balance. And so for a month, they ate a complete energy balance. And then for the next period of time, they were put into an energy deficit. So another month of time, they were put into groups to have 75% of their calculated daily caloric expenditure. All right, so they did a control, an energy balance, and then a deficit period, and we took a bunch of measurements throughout the time. We just wanted to point out that in the control group, the balance period, and then in the negative period, here are the protein percentages in calories and protein in terms of grams. So they had about 25% in the control period. When they went to the balance period, they were having 35% in the higher protein groups. Let me back up. So what this is looking at is basically what's called a traditional diet, and they ate 3 times per day, a high protein diet, which they ate 3 times per day, or a high protein diet in which they ate 6 times per day. That's what we're looking at here. And they did this over all those months that we had just talked about. And in the high protein groups, they had about 35% of their calories coming from protein. And in the traditional diet, it was about 16. As you know, that's what people tend to eat. Okay, so what happened? The fact here was that protein timing enhanced total and abdominal body fat losses. So high protein 6 times a day, shown in green, led to the largest overall reductions in total percent body fat, and as well as abdominal percent body fat measured by DEXA scan. So certainly there was some advantage to having higher protein multiple times throughout the day. High protein 3 times a day had a greater effect than the traditional diet 3 times a day, but eating it 6 times per day helped out, which sort of supports that previous data showing 4 20-gram boluses over the day was more advantageous there as well. And this is in terms of body fat losses, not really muscle gain in this context. Okay, so timing may be important in terms of spreading it out and just giving yourself the best opportunity to have a good result. It's a very minimal, but it might do something beneficial. And something that's related to this is eating before bed. And this is a group that a topic that my group studies all the time, which is going through what you eat before going to sleep. And what's really interesting here is that this is extending the original biology I was showing you early on, is the sleep window. So if you can optimize these sleep windows, which are green for muscle protein synthesis, if you don't eat, you have this negative portion for a long period of time while you're asleep. If you do eat, perhaps you have an opportunity to recover better or even to add more muscle mass. And so we've looked at this in a number of studies. These are two of the original ones. And what's interesting here is that when people had placebo, carbohydrate, whey protein, or casein protein before bed, it looked like the casein protein group was no different than the placebo in terms of fat oxidation, which means theoretically that you could have a casein protein drink and it wouldn't make you gain fat. It would actually not change compared to drinking nothing at all. And then if you did this over 4 weeks, which is this study, there were no significant differences over time in fat mass, but the protein groups, whey protein or casein protein, seemed to have some good directional changes in terms of fat mass. But again, it wasn't statistically significant. And we followed this up with some microdialysis work. This is to look at fat liberated from your fat cells in your belly. And when we did this work, we again showed no difference through the whole night if you ate something before bed. So no change in fat oxidation, no change in the mobilization of fat either, which is a good thing, meaning you can eat and not have a problem. And if we couple this with data from Luc Van Loon's lab with pre-sleep protein, in this case, they gave pre-sleep protein drink that comprised this 27.5 grams of protein, 15 grams of carbohydrates. Over time, in this particular study, they were able to show that the protein before sleep actually changed the quadriceps cross-sectional area size, so muscle growth, and also increased the total 1 repetition maximum over the 12 weeks. So there was an advantage to consuming protein at that time of night. All right, so where we stand now is that the optimal dose then seems to be somewhere between 0.3 and 0.5 grams of protein per kilogram of body mass per meal, which comes out to somewhere around 20 to 40 grams of protein per meal, depending on your age and your interests. We need to consider muscle protein breakdown in this whole scenario, and then protein intakes need to exceed the current RDA, especially for older folks, and especially when exercising. And then lastly, protein timing or distribution, which Dr. Arciero has coined as protein pacing throughout the day. Seems like it may play a role. It may be minimal, but it does seem to play a role in outcomes, especially on the body fat side. So here's your key takeaway. Optimal amount of protein will range based on age and fitness goal. Obviously, it needs to be individualized. Our third myth here is that eating a lot of protein makes you gain fat. So this comes from a lot of media portrayal of this, that eating too much of anything makes you gain fat. It looks like in the original work on this, there's lots of overfeeding data, which are really interesting studies to read. Overfeeding from any source makes you gain fat is sort of the crux of this. In the 2 studies, I'll just share a little bit of data that was shared to me by Dr. Antonio. Overfeeding 50% carbohydrate, 35% fat, 15% protein for 8 weeks. People in these studies gained fat, mostly in their upper body. So that's a pretty good macronutrient split, and 15% protein. So it's a pretty common way people eat. And a second study was looking at overfeeding of twins, and they gave a lot of extra calories per day, 840, and this was your carbohydrate, fat, and protein split, same as the other study. They did this for 100 days, and what they found was the subjects gained a lot of fat, a little bit of lean mass, but definitely a lot of fat with these big mixed meals. The thing about protein, though, is that it's been shown that increasing the protein dose from 15 to 30% in the diet decreases caloric intake and increases satiety, or the lasting effects of feeling less hungry. In this particular study, you can see there's different time periods of 15% or 30% protein, but the crux of it is this: over time, which is shown on the x-axis, energy intake went down, body weight went down with a high protein diet. The other side of this is shown here, in that hunger ended up going down and the feeling of fullness ended up going up. And so a higher protein diet may be advantageous in this way in terms of controlling overall body mass. Now, if we look at some of this great data from Bray's group, it was looking at 25 men and women. They did overfeeding for 8 weeks with 3 different protein loads: 5%, 15%, or 25% energy. Up top here, you can see body fat on the y-axis, overeating weeks on the x. Everybody gained fat. So eating too much had people gain fat. Now, here's the interesting part in terms of lean body mass in this study. The high protein group and the normal protein group, so 25 and 15% energy, both of those groups ended up gaining lean mass over time, whereas the low protein group, way down at 5% energy, ended up actually losing lean body mass. And so really, while they had similar increases in fat, the highest protein intakes actually increased lean mass, and the lowest protein intake resulted in reduced lean mass while also increasing body fat. So I thought that was an interesting one to share in terms of what's happening. Now, much more recently, Dr. Antonio's group has been on a real good kick of publishing data that looks at very high levels of protein. This particular one gave individuals all the way up to 4.4 grams of protein per kilogram of body mass per day. And interestingly, they did this for 8 weeks. They had no changes in body weight, fat-free mass, fat mass, or percent body fat. And this was in 30 young resistance-trained males and females. So that's a lot of protein to not have any change in those factors. And then more recently, they were comparing a control group, which, by the way, had 2.3 grams per kilogram of protein, which is very high anyway, and compared it to an even higher group, which was 3.4 grams per kilo. And in this particular study, they had 48 healthy men and women. They were performing heavy resistance training 5 days a week for 8 weeks. And the high protein group had the greatest loss in fat mass, and they had no change in lean body mass. So the changes by eating excess calories of protein ended up coming away positively in terms of losing fat mass, but no change in lean mass. And we published data over time as well with Arciero, who's from Skidmore College, and ended up showing that a 40% protein intake had the best decline over 12 weeks in percent body fat. 15% protein also had a reduction because they were exercising too, but just not as robust as the high protein group. So basically, where it comes to overfeeding, protein does not appear to make you gain fat, and high protein diets can help to reduce body fat and perhaps improve body comp, especially when you pair it with exercise. So take away high protein intake, will help your clients with body comp goals and won't make them gain excess fat. Now, what I want to hit last here is for weight loss, the myth of for weight loss, reduce your protein intake. That couldn't really be further from the truth, but the theory comes from a lower calorie intake to lose weight, right? We know we have to lower calories in general to lose weight. That's how every diet plan works. No matter what sort of fat it is, it ends up reducing calorie intake. And if you reduce all of them, then you should lose weight. Here's the trouble. What the data indicate is that eating protein at either 2 or 3 times what the RDA recommends, so the recommended daily allowance, is best for preserving muscle mass during weight loss. So these individuals were put on a 40% energy deficit and fed either the RDA 2 times the RDA or 3 times. And whether 2 or 3 times the RDA, it turned out that you ended up losing less muscle, and really being able to save that muscle mass would be critical. And you ended up still losing significant amounts of body fat. So in this case, it looks like 2 or 3 times the RDA is best if you're going into a hypocaloric or a weight loss scenario. Now, we mentioned this one earlier, but Dr. Joe, and before he left FSU, he ran this particular study, and it was individuals who are morbidly obese. And the bottom line here was that resistance training and a higher protein diet had some pretty magnificent results. So I want to draw your attention to 2 things. This is the resistance training group on the right and a control on the left that did not get resistance training. Both had a higher protein diet. The combination was able to basically save lean mass to a large extent, and there were no differences in fat loss. So that's a pretty amazing result. Draw your attention to the right side of this. Here's our control group and our resistance training group. If you were in the resistance training and protein group, the percent of your weight loss from fat was 96% versus only 76% here in the control group. And just as you'd expect, 24% of the weight loss in the control group was from muscle. So you're losing a ton of muscle. But in in the resistance training and protein group, only 4% of that loss was from muscle. So pretty amazing there. More recently, some publications have also been coming out in and around this area with large energy reductions, in this case 40% energy reduction, exercising extremely, all dietary things controlled, and comparing 1.2 versus 2.4 in the intake category. So big differences here. They had some carbohydrate intake was set to 3 grams per kilo, and they had a pretty big reduction here. So what happened over time was amazing. So it's pretty clearly shown body mass changes were not different between groups. The lean body mass changes actually increased with the high protein group, so the 2.4 group, and the fat mass changes were greater. So because fat mass changes were greater, but you actually did also gain a little bit of lean mass, improving your lean mass index or your body comp in general, meant no change in body mass overall, but the composition was better by adding more muscle and losing fat despite being on a hypocaloric diet. So where we stand now is that during weight loss, a high protein intake helps with fat loss and maintenance of muscle mass for sure. And that protein may be important in certain populations. Protein source, that is, may be more important for certain populations, but not likely an issue if you eat normally, or at least eat enough food. And that really comes from the next bullet point that I'll show you. But first, we'll show the key takeaway. Clients wanting to lose weight should aim for 2 times the RDA protein and include resistance exercise as part of your routine, and probably other forms of exercise as well, but most of these data are from resistance exercise. Now, that previous bullet was alluding to this, just protein type matter. We get this question a lot. I want to show a little bit of information. Many people believe that the muscle protein synthesis response is pushed by leucine alone, which is an amino acid that is known to trigger a cascade of molecular events that initiate muscle protein synthesis. Whey protein tends to have a high leucine ratio, whereas soy protein tends to be lower, pea protein and rice protein all tend to be lower. And what that means is that if you're not having enough leucine in your protein source, you probably have to eat more of it in order to have the optimal muscle protein synthetic response. So pretty clear that the vegetarian proteins, the plant-based proteins, will do the trick, but you need to combine them in order to have the same response as an animal-based protein, in this case whey, but there's also examples in other types of proteins as well. So the leucine threshold then is just the threshold that you need to achieve in order to have your optimal intake, and this is simply showing that in this hypothetical protein 1, it has enough leucine in order to trigger the best anabolic response. Just this week, publication is important in this area, was looking at protein quality, and I want to just show this across the board. They compared a ton of different sources like oat, wheat, soy, pea, corn, potato, etc., all to some other types like whey, milk, casein, egg, even to human muscle. And what I want to point out here is that this tall bar is showing the corn leucine percentage of total protein. So at first glance, you might say, oh, okay, so corn has a good amount of leucine. But it's important to note that it's percent of total protein in the product. So it's a very low amount of protein, but the protein that's there has a high amount of leucine as a percentage. You still would have to eat quite a lot of corn protein to have the same leucine amount as a smaller dose of some of these animal-based proteins. The other thing is it's not only about leucine. I think we're a little bit too hung up there. Certainly is beneficial, but we need to consider the essential amino acids. And something like corn that this paper described is missing lysine. And if you're just missing one of the essential amino acids, you're probably going to have some issues with maintaining a high rate of muscle protein synthesis and ultimately adding muscle or some of the functional outcomes like strength and power. So here's our summary of today's webinar, and these were to meet your the agenda from the day. So protein intake is a good thing for muscle gain or at least maintenance. It's a good thing for fat loss, as the data indicate. And it looks like body composition and weight control are certainly advantageous or made advantageous from a protein intake that's roughly between that 1.6 and 2.2 grams. Optimal dose per meal depends on age and fitness goal, but it looks like it's somewhere between 0.3 and 0.5 grams of protein per kilo per meal. What that comes out for an entire day is 1.6 to 2.2 grams of protein per kilogram of body mass per day. A few other points is that during weight loss, it's going to be advantageous to keep protein intake high. The data are showing that consistently. Some people recommend extremely high levels. There's one or two groups recommending over 3 grams per kilo in a weight loss scenario. And then distributing or pacing protein throughout the day may provide an advantage. That is a bit more controversial. The advantage is probably minimal, but it seems to be present. And lastly, exercise has got to be included. It really drives all of this, and it's the inclusion of exercise plus protein that's really going to provide the overall best results. So that's the summary of what we just went through, and I want to make sure that you're aware of some resources. These are some various things that I've worked on with Cliff Bar, which are the Active Nutrition Guide. What's really cool about this is that it serves a group that's been sort of underserved. It's not the elite group, and it's not the sedentary folks, and it's an active guide that is a great resource for folks that has these different pull-out menu items for different sports. It also has really good information for people who want to maintain an active lifestyle and all the macros, as well as advice on how to time things and really try to live life optimally. So there is a resource there that's completely free to download and goes through some of these protein nuances and things that I've talked about today. The other one is the ACSM online fitness journals and tutorials. There's so many good webinars in here. I'm just honored to be included in part of some of these, and it's another great resources for everybody to go after. Now, I just obviously need to thank my group. This is some of the team that's put together this work over time. As others have said, I get to do the presentations, but these guys do all the work. It's really a great group. Want to particularly thank Pat and Gustavo for helping me put together some of these slides, plus the Cliff team and Food Minds for helping with all of this, and some input from Stu Phillips and Paul Arciero and others. And particularly thanks to Cliff for sponsoring this. It's a great resource for everyone. I hope you all enjoyed it as much as I did, and for ACSM for hosting the webinar and putting this on as well. So with that, it's my pleasure to wrap this up, and I hope you enjoyed it, and I'm happy to take any questions in our remaining time.
Thank you, Dr. Ormsbee. A really great presentation, and we've had a lot of really interesting and I think well-founded questions come in. We have time, I think, for one quick question, and that is a practical question coming from your summary slide. Should the protein need be based on current or desirable body weight?
Yeah, that's a really, really good question. And there's data to both sides of that. And I would say the bulk of it is looking at current body weight, and then that'll obviously change as body weight shifts. There is some information to look at maybe ideal body weight, like where you want to be, or even lean body mass specifically. But I would start with a current body weight. Just in my practical application, I would just go by what I weigh now. And what's really good about these recommendations, I usually tell people to, regardless, aim for that basically a gram per pound of body weight, because typically we fall just short and you end up hitting right in the sweet spot between 1.6 and 2.0. So I would base that on my current body mass personally, and I think there's data that could support either way, and we just sort of need some more information about, one, how do you calculate that? Two, what does that mean to each individual? And three, practically, what sort of recommendations can you give someone that are any more useful than simply going after a current body weight of roughly a gram per pound?
Very good, thank you. For our attendees who submitted other questions, again, a reminder, we're going to be taking other questions from today's webinar and working with Dr. Ormsbee and putting together responses for those to post later on the ACSM blog. So look for further communication on that. Thanks again to everyone for attending, to Dr. Ormsbee for this really interesting presentation this afternoon, and to Cliff Bar and Company for supporting today's webinar. As a final reminder, an email with a link to your CEC along with a PDF copy of today's slides, and a recorded version of the webinar will be sent within the next 1 to 2 days. Also in that email, there will be a short survey, and we'd appreciate your feedback on today's session so we can continue to offer these and improve. Have a great afternoon, and this will conclude today's webinar.
Thanks, everybody.